students. In today's lecture, we are going to discuss the problem from discrete time Fourier transform. So we are discussing the previous year question paper. So the given problem is compute the discrete time Fourier transform of the signal x of n equal to a to the power of mod n, provided the condition is mod a is less than 1. This condition is very important to bring the results. Okay, so let's start. We know the definition, the formula to calculate the discrete time Fourier transform. So the discrete time Fourier transform x of omega summation n equal minus infinite to plus infinite, the input x of n e to the power minus j omega n. This is the formula. What is x of n here? X of n is a to the power mod of n. Okay, now this a to the power mod of n can be written as a to the power of n when n value varies from 0 to infinity, whereas this x of n becomes e power minus 7 when n varies from minus infinity to minus 1. Okay, the range of n is minus infinity to plus infinity, and since this is mod of n, which includes all the positive and negative values of n. If we take negative values of n, the limit varies from minus infinity to 1, and if we take positive values of n, limit varies from 0 to infinity. So therefore this x of omega can be written as summation n equal minus infinity to minus 1. What is x of n? X of n is a power minus n e power minus j omega n plus summation n equal 0 to infinite. What is x of n here? A power n e power minus j omega n. Okay, we have separated the summation from minus infinity to plus infinity into two parts. Now we'll simply apply the formula and we have to calculate the answer. What is that simple formula? Uh, let's say this is summation n equal minus infinity to minus 1. I am taking the a power as 1 as common, that is a e power j omega whole power minus n plus summation n equals 0 to infinite a e power minus j omega whole power n. Okay, now we know the standard formula for this. What is the standard formula? We know the summation n equal 0 to infinity a power n can be written as 1 by 1 minus a if the value of mod a is less than 1. Okay, so now if we apply the same formula over here, let's write the terms over here. So the summation n equal minus infinity to minus 1. What is that? A e power j omega whole power n minus e power j omega whole power minus n plus summation n equals 0 to infinity a e power minus j omega whole power n. Now this can be written as n equal minus infinity to minus 1 a e power j omega whole power minus n. This can be written as 1 by 1 minus a into e power minus j omega, provided the condition mod of a e power minus j omega is less than 1. It's right. So we'll get mod a here, and the modulus of e power minus j omega value is 1. Therefore we'll get mod a power. The condition is satisfied, so that we can write this summation into a simple formula. Now we have a term here. How do we write this? Now the power will be in terms of minus n, and even the summation value ranges from minus infinity to minus 1. Let's take m equal to minus n. Let's change the variable in the summation, n equal to minus m. So therefore we'll get, therefore n equal to minus m equal minus infinity, then a e power j omega whole power n plus 1 by 1 minus a e power minus j omega. So now here the variable is infinity, so the negative, and here is also negative, so both cancels. Now I am rewriting, this is m equal to 1 to infinity. Even if we vary from infinity to 1 or 1 to infinity, both are same. So a e power j omega whole power n plus 1 by 1 minus a e power minus j omega. Now if I expand this equation, I'll get a e power j omega, the first term, plus a e power j omega whole square plus a e power j omega whole cube, and it will goes on up to infinity. What is the second term? I have e power minus j omega. Now if I take a e power j omega as common, I'll get 1 plus a e power j omega plus a e power j omega whole square plus etc. Now this can be written as summation n equals 0 to infinite a e power j omega n. Because if I substitute a into e power n equal to 0 here, I'll get 1. If I substitute n equal to 1, I'll get a power j omega. Okay, now we get the standard format, and now the answer is a e power j omega. Now this answer is 1 by 1 minus a e power j omega plus 1 by 1 minus a to the power minus j omega. Now this is the answer for the given question. Thank you.